to my video lecture on loop analysis of resistive circuit in the context of DC voltage and currents. Myself, Renewable Energy Assistant Professor of Electrical Engineering Department of Engineering College. In my previous lecture, we have learned about basic laws of circuit theory and then Kirchhoff's current law, Kirchhoff's voltage law, mesh, loop, and definition signals and basic signals we have already learned, and various kinds of superloop concept, supermesh concept, those things are highlighted in the previous lecture. In this lecture, we will concentrate mainly on the loop analysis of DC resistive circuit, and we will see that how the mathematically can be solved by using loop analysis or Kirchhoff's voltage law, apply Kirchhoff's voltage law. So here we have taken one example. Let us consider solution of electrical circuit based on mesh or loop current method. Let us consider this simple circuit shown in this figure to find out the currents to different branches using mesh loop current method. So here we have taken our circuit. We have three voltage sources are there. This is DC, this is VA, and this is VB. Three voltage sources are there, and three loops are present. Loop 1, this one is loop 2, and this is loop 3. Three loops are present. That means we will form three loop equations, and solving these equations we will find the branch currents or loop currents here. So applying KVL in loop 1, Kirchhoff's voltage law means summation of voltage drop and EMF present in that closed loop equals to 0. So here we have applied Kirchhoff's voltage law in loop 1, and in loop 1 we can see there are two voltage sources. We can see VA in the positive direction and DC in the opposite direction. So the equations will be VA minus DC, then voltage drop across R2, that is R2 into I1 minus I3. The concept here is the voltage drop across the resistor will be the loop current which is present or which loop we are concentrating. That current will be first, and whatever another loop which is disconnected, that current will be minus. So here it is current, we are calculating the loop current or loop, we are forming the equation of loop 1. So the drop will be R2 into I1 minus I3. Similarly, the drop across R4 will be I1 minus I2 into R4, and that all equals to 0. So calculating this one, we are getting this equation 4.1. Okay. Now applying KVL in mesh or loop 2, and we will get similarly here only voltage source is present VB, and the direction of the source is just opposite to the direction of current. We have considered that the current is in this direction. So the voltage source present here, the direction is opposite. So it is minus VB, and definitely a drop we will calculate in a similar way. That means now we are present in loop 2. So definitely the current of loop 2 will be first, that is I2, and it is connected with adjacent loop of I1. So it will be I2 minus I1 into R4, and also another resistance is R3. It is connected with loop 2 and loop 3, and we are concentrating on loop 2. So it will be I2 minus I3 into R3, all equals to 0, and we are getting the equation 4.2. Now applying KVL in loop 3, definitely in loop 3 we have one voltage source DC, and the direction of the voltage source is same as the direction of current. So it is plus VC, plus I3 minus I1 into R2 plus R3 into I3 minus I2 plus R1 I3, and these all are equals to VC. That is the equation we have got here, 4.3, and in general you can write all the equation in this generalized form. Summation of VII equals to minus R1I I1 minus RI2 RI minus RI I1 minus RIN IN. Simply by means it takes algebraic sum of all the voltage sources around ith mesh. RII means the total self-resistance around ith mesh, and RIJ means the mutual resistance between the jth mesh. So generally Rij equals to RJI, true only for linear bilateral circuits. So here the unknown mesh currents for the network. Now we are summarizing it in short. Step 1. Draw the circuit on a flat surface with no conductor crossovers. That is the step 1 part here. Draw the circuit on a flat surface with no conductor crossovers. Step 2. Level the mesh currents carefully in clockwise direction. Step 3. The mesh equations by inspecting the circuit. Number of independent mesh or loop equation equals to number of branches and no principal nodes. Number of principal nodes equals to n plus 1. So note that to analyze the resistive network containing voltage and current sources using mesh equations method, the following steps are essential. First one, if possible, convert current source to voltage source. Second, define the voltage across the current source and write the mesh equations as these source voltages are known. Augment that the set of equations with one equation for each current source expressing known mesh current or difference between two mesh currents here. Mesh analysis is valid only for circuits that can be drawn into two-dimensional plane in such a way that no element crossover another. Okay, that means we have to simplify the loop, then point out the loop currents, and then form the equations. That is the main concept here. Now we will take a mathematical problem. Let us consider this one. Find the current through AB branch and voltage CG across the current source using mesh current method. That means we have to find the voltage between C and G. This one, this voltage we have to find, and the current IAB. That means this current we have to find. Okay, using mesh current method. So taking the solution, assuming that the voltage across the current source is V1 and C is the highest potential or higher potential than G. G is the ground potential here. We are assuming this value is 0. And note that I2 is minus 2 ampere as it is given 2 ampere. So the direction here it is opposite, so it is minus 2 ampere. Next, applying KVL in loop 1, we are getting VA minus I1 minus I3 into R2 minus I1 minus I2 into R4 equals to 0. And that is this loop equation. Definitely R2 is connected with loop 3 and loop 1, so it will be R2 into I1 minus I3, and R4 is connected between I1 and I2, so it will be R2 into I1 minus I2, and the voltage source direction is positive, so it is positive here. 3, 4. Putting all those values, we are getting 3I1 minus I3 equals to minus 1. Now loop 2 equation we will put similar way. Let us assume that the voltage across the current source is V1 and its top end is assigned with a positive sign. So similarly we will get the equation 2 for loop 2, and not assuming, it is already given that I2 is minus 2 ampere. So in loop 3 similar way we are calculating the values, and we are getting that equation I1 minus 8I2 equals to 8. Now calculating all these values I1, I2 and I3, we are getting this one. I1 equals to minus 0.6956, I3 equals to minus 25.583, that is minus 1.0869. So we have to calculate IAB, that means that IA minus IB, that is I1 minus I3. So our result is 0.39. That is our answer. So considering the negative sign of current means that the current flows in reverse direction here. In our case, current flows through 4 ohm resistor from C to B. As per diagram, we can easily see it that the current flowing from C to B, this direction. And we have taken this one, and actual current is flowing in this way. So this answer we are getting is minus. So we are getting from the equation the value of voltage between C and D, that is 6.27. In another way we can also calculate it, like minus V1 plus VPD plus VDC, that is summation of voltage drop equals to 0, and from there we can calculate the value of VCD, that is 6.27. Another example we are taking here. Here we have to calculate the value of Vx using the mesh current method. So here we can see that we have two voltage sources, and one voltage source is connected with a series resistance, and we can say this voltage source is also connected with a parallel resistance. In another way we can see that this current source is connected with this parallel resistance. That means for easier calculation, I have already said that always try to convert that current source into voltage source for easier calculation. So here we will convert that current source into voltage one. That means this 6 ampere current source parallel with 6 ohm. This part I have taken separately, and we will convert this one to voltage source. So what will be the value of voltage source? 6 into 6, that is 36 volt, and this resistance 6 ohm will be connected in series. So this part has been changed. Now we will again form the actual circuit using that source transformation technique, and our new circuit becomes this one. That means 6 ampere with parallel 6 ohm resistance is now converted to 36 volt 6 ohm in series. Okay, so now the total equation or total circuit became a simple circuit of 2 loops. So we have written the equal equation, that is Vx minus I1 minus I2 into 3. This current I3 ohm is connected between 2 loops. So the voltage drop is 3 into I1 minus I2 minus 18 volt, which is minus because our loop current direction is this and this voltage direction is opposite. So it is minus 18 equals to 0. Similarly, we have written the equations for loop 2 also, and calculating these two equations, we will get the value of voltage Vx is 48 volt. Okay, so in this way we can calculate the mesh or loop currents easily by applying Kirchhoff's voltage law in loops. So practice all these problems from different books, and here this total notes is taken, or we have taken the help of NPTEL lectures, and you can also follow the NPTEL lectures also. And of Abhijit Chakraborty's book of circuit theory, I will prefer for circuit analysis and solution of different mathematical problems. Thank you for listening my lecture.